Hey everybody, it's Mr. Z coming to you live on a Tuesday morning. And today we are looking at parent functions. And they go to graph and something completely bizarre shows up. Well, let's undo that. That's very interesting. Okay, that's way too thin. Here we go, kids. So let's take a look at quadratic equations. Oh, yes, quadratic. Why is squared quadratic? Because it has the word quad in it. So, y equals x squared looks like this. However, if you want to move it up and down, you need to add something onto the end so that all the values move up or move down. So that's that. So that takes all the values and subtracts 4. Now, along the same lines, if you put a negative in front, like y equals negative x squared, it will flip upside down because when you put in a positive, you get a negative. When you put in a negative, you also get a negative. Because when you square something, you get a negative, excuse me, you get a positive, throw a negative in front, it'll flip upside down. Now, let's clear and take a look at how to move it left to right. How do you move it left to right? So, in order to move any function left and right, you must increase your bust. You must move the 0. So before, when I put in 0, I got 0. Now, when I put in 2, I get 0, which means now if I put in 3, I get 1. If I put in 1, I get 1 minus 2 is negative 1 squared is 1. So all I did was move the graph over to 2. Notice the horizontal shift. Where did I move the 0 to? 2. Notice it says x minus 2. So it really says x minus the shift. In other words, where is my new 0? Where is my new 0? So now if you want to move it over and down, well, let's see. Where is the vertex? It moves 3 to the left, and it just so happens to move 3 down. Because this moves it down, it moves 3 out of everything. Sorry, it subtracts 3 from everything. And the only way to move it left and right is to affect what we call the argument. Arguments! We're all good at arguments. So if I go to -3, I go wee! And of course, if I stick a number in front, like 3, for instance, I can make it all 3s. Yay! It will get steeper because everything will be 3 times as high. And one of the things that you can do to help take care of you when you graph, say it looks like this. Okay, so this is the shape. Notice it's kind of flat. This determines where it sits on the x-axis. So when x equals 1, and now the y coordinate is 5. So the vertex is 1, 5, and it's kind of flat. So here's a little secret for you. Oops. Let's just straighten that out. So if we go to 1, 5-ish, and now go up 1 over 4, up 1 back 4, it gives you a feel for what the graph looks like. Now, if you want to see it in real time, so I go to 1, 5, and now I'm going to go up 1 over 4, up 1 over 4, and that gives me a feel for what my graph looks like. Because it has a vertex at 1, 5, and it had a 1/4 in front, which means instead of it going up 1 over 1 for the first point, it will go up 1 over 4. And so there is your essence of vertex form. If it doesn't have anything on the end here, it'll just move to the side. So we can actually just do this one. The vertex, again, zero it out. Excuse me, there's a square missing there. Zero it out, and it doesn't move up and down. And you can prove it. Plug in -4, you get 0. So this actually has a double 0 at 4. And we'll zoom this, make it a little skinnier. So we go to -4, and we go down 2 over 3. Follow that slope. Down 2 over 3, down 2 over 3. La la la, connect the dots. And that gives you a feel for what the graph looks like. So this is called HK form. Y equals x minus h squared plus k, where the vertex is at HK, which essentially means zero this out and take this. Some people like to say opposite same, but if the inside is more complex, then you have to actually solve to set that equal to 0. So zero it out, move it, zero it out, move it, zero it out, move it, zero it out, move it. And that is graphing a parabola in vertex form. The beauty of that is that every single graph works basically the same way. You determine the shape of the graph, find the vertex, and go from the vertex. If you follow that little slope that's in front, it will help you find the first nice point. So if you go, even if you have asymptotes, you have a center of the asymptotes, you follow that slope down 2 over 3 or down to back 3, depending on which way you're looking. And then that tells you where the beginning of the graph is. But this is graphing parabolas in vertex form. Notice it tells you the vertex. It doesn't tell you anything but that. But if you know where the vertex is, then you can figure out where the other zeros are, and you can do a little bit of math from there. Have an excellent day. Please pass the word.